Hi everyone, welcome to our next unit. In this unit, you're going to be looking at multiplication by two-digit numbers. Today, we're going to look at the strategy, multiply by tens. Make sure to copy down the title of this lesson onto your notes. Our learning goal for the whole unit is how can I use place value to multiply a two-digit number by another two-digit number. For today's lesson, we're looking strictly at what strategies can I use to multiply by tens. Let's start out by remembering what we already know. In our last unit, we learned to solve 5 times 30 by thinking of the basic fact 5 times 3. We can solve 5 times 3 easily. It's 15. But since I'm multiplying 5 times 30 and not 5 times 3, my answer is 150. I can repeat this pattern to multiply 5 times 300 to get 1,500 and 5 times 3,000 to get 15,000. Now let's see what it might look like in a word problem with two digits. Animation for a computer-drawn cartoon requires about 20 frames per second. How many frames would be needed to draw for a 30-second cartoon? In this problem, the question is, how many frames would need to be drawn for a 30-second cartoon? The problem tells me that I'm going to use 20 frames per second. That gives me the problem of 20 times 30. I can solve the problem 20 times 30 using place value and think of 30 as 3 tens. So instead of 20 times 30, I'm going to think of 20 times 3 tens. 20 times 3 uses the basic fact of 2 times 3, which is 6, and then I add my 0, so 20 times 3 is 60 tens. 60 tens would be 600. I can solve the same problem of 20 times 30 using another strategy. I could use the associative property to group numbers. And instead of thinking of 30 as 3 tens, I can think of 30 as 3 times 10, giving me 20 times 3 times 10. I can easily solve 20 times 3 using my basic fact. 2 times 3 is 6, so 20 times 3 is 60. If I multiply 60 times 10, my basic fact 60 times 1 is 60, and then I add my 0 for the 10, still giving me 600. Let's connect this to what we already know. I'd also like you to copy the examples on this page, as well as answer the question on the bottom. When we multiplied 5 times 30, we used our basic fact of 5 times 3 and then added the 0 since it was 30. We repeated that process for 5 times 300, instead adding 2 zeros, and 5 times 3,000, adding 3 zeros. We can do that same strategy here with multi-digit numbers. In 50 times 30, my basic fact is 5 times 3. 5 times 3 is still 15. This time, however, the 50 has a 0, and so does the 30, which means I need to add 2 zeros in my answer for 1,500. I can continue that pattern for these other problems. 50 times 300 still has the basic fact of 5 times 3, which is 15. Only now 50 has 1 0, 300 has 2 zeros. So I add the 3 zeros into my answer to get 15,000. 50 times 3,000 still uses that basic fact of 5 times 3, only now 50 has 1 0 and 3,000 has 3 zeros. So I need to add 4 zeros to my answer, giving me 150,000. I can do this again for the number 500 times 300. My basic fact for 500 times 300, my basic fact is still 5 times 3. 500 has 2 zeros. 300 has 2 zeros. So I add those 4 zeros to my answer, giving me 150,000. Take a look at these examples and compare the number of zeros in each factor to the number of zeros in the product. What do you notice? Pause the video and write down an answer. We'll discuss this tomorrow as a whole group. But what do you do if your problem only has 1 zero? Let's solve 14 times 30 using place value. For 14 times 30, I can use the basic fact of 14 times 3. Now, I can't solve 14 times 3 in my head, but I learned how to solve 14 times 3 in the last chapter, using multiple strategies. 4 times 3 is 12. 3 times 1 is 3, plus 1 is 4. So 14 times 3 is 42. But since my problem was not 14 times 3, but instead 14 times 30, I'm going to add the 0 into my answer, telling me that 14 times 30 would be 420. I could also use mental math strategies to solve 14 times 30. Since 14 is an even number, I can split it in half. Half of 14 is 7. Since I took half of 14, I could use the strategy of half and double double 30. Double 30 is 60. I could find the answer to 14 times 30 by solving 7 times 60. The basic fact in 7 times 60 is 7 times 6, which is 42, and I put that 0 in my answer, telling me that the answer is 420. So 14 times 30 is also 420. Let's do one more example together. This time, write down this example in your notes. The Hart family drove 10 hours to their vacation spot. They drove an average of 48 miles each hour. How many miles did they drive in all? Since my question is how many miles did they drive in all, I know that I'm combining information. The information that I have is that this family drove 10 hours to their vacation, and that they drove 48 miles each hour. If they drove 48 miles each hour for a total of 10 hours, I can solve this problem using multiplication and multiply 48 times 10. I can solve this problem using the strategy of zeros and think of 48 times 10 as 48 times 1. 48 times 1 is simply 48. I can then add that 0 into my answer to get 480. I can also solve 48 times 10 using the multiplication strategy of half and double. I can take half of 10 and get 5. and I can double 48 by adding 48 to itself 2 times, and get 96. I know how to solve 96 times 5 because I've already done single-digit multiplication. So 96 times 5, 5 times 6 is 30, and then 5 times 9 is 45, plus 3 is 48, giving me an answer of 480. It's time for your check. Complete the lesson check that accompanies today's video. Be sure to include the work for these problems on the notes for today and bring them with you to class tomorrow. We will start by reviewing these problems as a whole group. Remember, if you're having problems, go back and watch the video again. Look at the examples and see if you can solve them in the same method. Have a good night.